Alright, so today we're going to talk about congruent triangles. So originally we talked about similar triangles. So let's just do a little bit of a backtrack. Okay, remember, to be similar, they are the same shape, but they're different size. They're dilating. Either they're shrinking or they're enlarging. And think back, remember that when we look at similar triangles, remember their sides are proportional. AB is proportional to DE. AC is proportional to DF. And BC is proportional to EF. Okay, sides are proportional, but the angles, corresponding angles, are congruent to each other. They're still the same measure. Whenever you change the shape, change the size, and the shape stays the same, the angles don't change. All the angles, corresponding angles, are congruent. And now, what we're going to do now is, keeping this in mind, refreshing your memory of similarity, let's see what's different when we talk about congruent. So, congruent triangles, they have the same shape and size. They're equal. It's like these two sheets of paper over here. Even though I have them rotated, even though it's rotated, there's still a rectangle. Still a rectangle. Their shapes didn't change. The only thing that changed was their orientation. I moved it around. So, triangle with same shape, same size. This means all corresponding parts. Parts are angles and sides. All the parts of a triangle, the angles and sides, are congruent. Okay, congruency is nice. Same size, shape, same shape. It's like these two desks are the same. Same size, same shape. All parts are going to be congruent. So, let's talk about statements. So back here, we would say, okay, if I prove the triangle is similar, then I can say triangle ABC is similar to triangle DEF. Once we prove it, remember we had postulates for it, we could say, okay, those triangles are similar because I know their sides are proportional, angles are congruent. Well, once we prove triangles congruent, once we prove it, we know it, we write a congruency statement as well. Now, instead of the tilde for similarity, congruence is where you have the tilde with an equal sign. That means these triangles are congruent to each other, okay? So in the end, if I see, hey, they put tick marks. One tick mark, these sides are congruent. Two tick marks, these are congruent. Three tick marks, those are congruent. And they also have corresponding angles, congruent. All the parts are congruent, so I can write a congruency statement. And they were so nice enough to say it to you already. Now, remember, consistency is not going away whenever you write your statements, your corresponding sides, and corresponding angles. Okay? Now, once we show that two triangles are congruent, give me a second, it's being annoying. Okay, once we've shown two triangles congruent, we can then say that, okay, if the shape and size are congruent, well, once I prove the triangle's congruent, I know all their other parts are congruent. Okay, we're going to go back to postulates. So remember, similarity was SSS, SAS, and AA. Okay? Congruency will be different postulates, but once I show by that postulate, I know the rest of the parts are congruent. We call this CPCTC, right? Sounds weird. CPCTC, that means corresponding parts of a congruent triangle are congruent. Sounds weird. It's a weird phrase. Now if you need to, pause this video so you can write as I write. So I'm just going to keep going, okay? So once I show two triangles are congruent, I know that all the other parts of that congruent triangle is also congruent, okay? So when I know by that postulate, let's say I use SSS for congruency. When I know all three sides are congruent, so my triangles are congruent, what other parts are there? Angles. So I know that the angles are congruent as well. And that is all CPCTC is saying, okay? So, now, back to, this might look familiar, like in similarity, where I had you write the corresponding sides and corresponding angles. Okay, it says to complete the angles and sides of your congruency statement. So if I look at number 1, remember, your statement is your best friend. Now if you want, you could draw two triangles, label their sides, and see it visually. But if I have my statement, that's my best friend in the world. So if I look, angles, well, I'll have angle J is congruent to, well, first position of the other, angle B. I have angle K is in the middle, corresponding angle would be Q. Last letter, L, same position, last letter, R. These are the three pairs of angles that will be congruent to each other. Okay? Now the sides. Now, back in similarity, you had to write fractions because they're proportional. Same scale factor, dilation. Congruency is beautiful. Everything is congruent. All right? So all the angles are congruent, the corresponding sides are congruent. So I'm going to look. I have, remember, two letters for a side. JK would be congruent to PQ. They're both the first two letters. Okay? Last two letters, I have KL is congruent to last two letters, QR. Okay? Then I would have, I did first and second, second, third. Let's do first and last. So JL is congruent to PR. I just listed all angles corresponding are congruent, all sides corresponding, remember same position, but in the other triangle are congruent. That's it. They all have the same measure. These two sides have the same measure, same length. These two sides have the same measure and length, and so on. These two angles have the same degrees. Remember that definition of congruence? If the angles are congruent, then the measures are also equal. If the sides are congruent, then the sides are also equal. Definition of congruence, back to proofs. All right, now once I've shown this, it says write another valid congruency statement. Well, remember, I had told you consistency. Best friend in the world, whether you like it or not. Congruency statement. So instead of JKL, I know some of you might write it backwards or something, but I want to do something a little more challenging. So I'm going to say triangle KJL. So if I look at that, the pattern I chose, KJL, middle, first, last. Consistent. I would say it's congruent to triangle. I did second, first, last. So second is Q, first is P, last is R. That's another congruency statement. Okay? So pause this video, and I want you to try out number 2. Okay, pause it now. Okay, now, hopefully you paused it and you tried it, or I'm going to slap you. I'm just kidding. All right, now, if it was angles, now if you had angle E switched, you had angle E first and angle W last, that's fine, but they're still corresponding to each other. You're good. Angle X would be with angle F, angle Y would be with angle G for angles. Now sides, 2 letters. You'd have WX, EF, they are congruent. XY, FG, they are congruent. WY, EG, they are congruent. Ta-da! And then some of you may have done this, which is fine. It's just, I kind of expect it. You might have written this backwards, but just make sure you're congruent going backwards. So GFE. That's it. All right. I'm going to stop this video. This is like part 1, introduction. There'll be a part 2, maybe a part 3. Okay, with short videos. Alright, so here we go.